All right, guys, just got finished doing 2 days of finding limits both numerically and graphically. And now we're going to take a couple of days and learn how to find limits algebraically. Quite a few rules on these things, so this would be a good day to take notes on the video so you have these laws down. There's several of them, just warning in advance. And you get them down, get your phone, take a picture of them or something so you have them. Okay, so here we go. The first is 5 of them. All right, I'm just going to go through one at a time right here. If you have a limit as x approaches a of 2 functions added together, you can break it up separately and just add them. Okay, that's called the limit of a sum. Same thing with subtraction. You got a limit of as x approaches a of 2 functions subtracted. You can take each individual function, the limit, and subtract your and find the difference of the two. If you have a limit of a function multiplied by a constant, you can find the limit of the function first and then just multiply it by the constant. If you have the limit of 2 functions multiplied together, you can find each limit individually and then multiply the 2 limits together. And the last one here, if you have 2 functions that are divided, you can find the limit of 2 functions that are divided. You can find the limit of each function and divide that as long as the bottom one limit is not 0. Okay, in words, it's like this. The limit of a sum is the sum of the limits. The limit of the difference is the difference of the limits. The limit of a constant times a function is the constant times the limit of the function. The limit of a product is the product of the limits. The limit of a quotient is the quotient of the limits. So you're basically saying you can break it up. All right, 2 more. If you have a limit of a function that is raised to a power, you can find the limit first and raise your limit to the power. If you have a limit of a root of a function, you can find the limit of the function and then take the root. So again, just in words, the limit of a power is the power of the limit. The limit of a root is the root of the limit. Okay, so you're basically saying you can break it up and do the operation last. Okay, let's try a couple using the graphs. Okay, this first one I see, it says the limit as x approaches -2 of f of x plus 5 times g of x. Okay, so the laws we just did say I can break that up. I can do the first one. I can find the first limit. I can find this limit, f of x. And I can find the second limit, and I'm going to do 5 times that one, obviously. 5 times limit of g of x, and just add those together. That looks like Slims or something. That's a g right there, and that's a 5. As x approaches, I probably shouldn't have tried to copy that because it's written right there. I just broke it up into 2 pieces. So look at function f. As function f approaches -2 from both sides, look what it's getting. It's getting closer and closer to 1. So that's 1. Plus 5 times. Look what function g is as it approaches -2. Function g is it's getting closer to -2 from this way and this way. It's getting closer and closer to -1. So I would do 1 plus -5, which is -4. And that's the answer to A. Okay, I did each limit, look at the graph, got the limit, and then just added them together. Okay, let's look at the second one here. Second one says limit of f of x times g of x as x approaches 1. Watch what happens here. As I look at f as it approaches 1, it's getting closer and closer here, closer and closer there. It's getting closer and closer to 2. So it's going to be 2. I'm breaking it up again. Now I'm going to find g of x. As g of x is closer and closer to 1, now look what happens. On that side, it's getting closer to -1. On this side, it's getting closer to -2. So because they're different on each side, that limit doesn't exist. So I can't multiply something that doesn't exist. So this limit does not exist because the second one did not exist. And that's okay. Let me erase these things. Okay, the third one. The limit of f of x over g of x as x approaches 2. Okay, so I'm breaking them up. I'm going to do the f of x first on the top. As f is approaching 2, it's getting closer right there, closer and closer. I'm going to say that's about 1.4. And as g of x approaches 2, that's this one, the blue one. As it's getting closer and closer to 2, it's getting closer and closer to 0. And because you cannot have 0 in your denominator, that also does not exist. Do not be surprised when a limit does not exist. That's completely okay. And the last one right here says the limit of f of x cubed as x approaches 1. So I'm looking at f only. As f approaches 1, it's coming there, it's coming to that side also, and it's getting closer and closer to 2. So the limit of f of x as x approaches 1 is 2. You just have to cube that, and everybody knows 2 cubed is 8. So there's how you do those laws of limits graphically. All right, there's some special cases. of limits. These are going to be important as we continue on. If you have the limit of a constant, that C stands for constant. That's not like a number. Like limit as x approaches to a 4. That's going to equal 4. Whatever the constant is, that's what it's going to equal. If you have just x, all right, limit as x approaches a of x, that's just going to equal a, whatever number is down here. Okay, whatever number's down there, that's going to be what your limit is if you just have an x. All right, if you have an x with an exponent, you're just going to do the a down here to the power. And the last one, if you have a root with an x, now these are all x's, okay, all x's, then you just take the root of the a, and you can't see it down there, the root of what you're approaching. All right, so one more time. If you have a constant and it's a limit, the answer is the constant. If you have an x, just an x, the limit is the number you're approaching. If you have an x with a power, the answer is the number you're approaching to the power. And if you have a root, the answer is the number you're approaching, the root of that number. Let me show what I'm talking about. Okay, it says evaluate the following and justify each step. We're not going to justify, we're just going to evaluate. And here inside here I have addition. We've already talked about this today. You can break that up, each one. So I'm going here, I'm going to go 5, 2x squared minus a limit of, as x approaches 5, of 3x. I'm going to do limit as x approaches 5 of 4. Okay, we learned earlier if you have a constant multiplied in your limit, you can do the limit of what's in here and then take care of your constant. So I'm going to take that 2 to the front. Same thing on this one. I'm going to take that 3 because it's a constant to the front, because you can multiply the constant times the limit after you do the limit. This one, that's a constant, limit 4. So remember, whatever, if you have a constant there from the last slide, that's just 4. Right now, we just had this on the last slide also. If you have an x squared, what I'm going to do is I'm going to take the number down here, and it just goes in there. Okay, so I'm going 2 times 5 squared. Same thing here. If it's just an x, you just put that number in for x. 3 times 5. That's the limit. That's the limit. That's those special cases we just looked at. And then I'm going to work it out. 5 squared is 25 times 2. That's 50. That's 15. That's 4. That's going to be 39. So the limit, that big limit right here, is 39. All right, using those special rules. All right, let's look at another one here. Same deal. I'm going to break this one up, top and bottom. So that's a lot of pieces, but we got to do it. So I got limit as x approaches -2 of x cubed plus limit as x approaches -2 of 2x squared minus limit as x approaches -2 of 1 over, still going, limit as x approaches -2, a lot of writing on these notations, 5 minus limit as x approaches -2, 3x. Okay, here we go. There's an x and it's x cubed. So remember, all we do is we put the -2 in there. So it's going to be -2 cubed plus, remember this right here goes in the front. The 2 goes in the front. I'm going to plug in that one because it's an x squared, so I get -2 squared. And the last one is just a constant. When you have a constant, the answer is the constant. There's the numerator. The denominator, the 5 is a constant, so it's just 5 minus, again, the 3 is going to the front, and then because it's just x, it's -2. So I'm going to have my 3 times -2. So if I work out the numerator, that'd be -8 plus 8 minus 1. If I work out the denominator, it's 5 plus 6, that's 11. So it looks like it's going to be -1/11 right there. So the limit of that whole thing is -1/11 because of the properties that we just did or just learned. It's a lot of stuff. All right, last thing today. Limits of direct substitution. This is a huge one. It's going to make your life so much easier and better if you can understand what it's saying. This one says if f is a polynomial, you gotta know what a polynomial is. It's things like this, x squared minus 3x plus 2, stuff like that. That's a polynomial when you have no negative exponents, no x's in denominators, and we'll talk about more about polynomials tomorrow. A rational function is a function that is a fraction. Okay, a rational is a fraction, usually with x's in your numerator and x's in the denominator. That's rational. And if that's the case, if you have one of those two types, you can find the limit using direct substitution. You can just substitute the number you're approaching into your function and get your value. Let me show you one or two. Okay, this first one right here, that's a polynomial. That's what a polynomial looks like. And because it's a limit of a polynomial, we're allowed to use direct substitution. So I'm going to do 2 times 3 cubed minus 10 times 3 minus 8. Okay, 3 cubed is 27 times 2 is 54. That's 30. That's 8. I believe that's going to give me 16 right there. So the limit as x approaches 3 of this is 16. The second one, if you look at this one, it's rational. It's a fraction. Okay, so because it's rational and a fraction, you can use direct substitution. You can take the -1 and substitute it for your x's. Okay, I get -1 to the 4th down here plus 2. So my numerator is going to be 1 minus 5. My denominator is going to be 1 plus 2. That looks like I'm going to get -4/3. And there's your limit as x approaches -1 of that function. Again, you can use direct substitution when you have a polynomial or a fraction. All right, that's a lot of stuff for this video. Hope you took some notes. We'll work on it tomorrow as usual. See you then.